All right, so we are good to go. I have pasted the YouTube link in the chat as well as in the calendar also. So you can access in uh, both the places. Okay. So today we are going to solve couple of problems, not couple. We will solve some 5 problems which are replicas of your graded assignment questions. Okay, so you would have seen those questions in your graded assignment week 3. And this is the third session for week 3. So if you want to look at the previous 2 sessions, you can just go to the YouTube and it is available, or it is available in the calendar also. So let me repeat what we are going to do today. So today we are going to solve problems, and those problems are actually replicas of your graded assignment questions. So once you are able to solve these questions, then it implies that you will be able to solve the graded assignment questions also without any issues. But those who are unable to solve these questions, learn it in this particular session so that you can use the same knowledge that you have gained in this particular session to solve the graded assignment questions. Okay. And yeah, so for each problem, I will give some time to you guys. And I also start a poll in the Gmeet. Okay. So you reply to that poll. So that poll will be like question 1, have you solved it? So options will be like yes, no, something like that. Okay. So right after every question I show, I will put a poll in the Gmeet, and those who have joined, you should attempt that poll. Okay, so that is how we consider whether you are in the session or not. So people can simply join and then leave the phone and go somewhere, watch movies or cricket. So if people are doing like that, then they won't get this idea of poll and answering it. So what we have come up is now there is no escape. So if you are sitting, if you join the session, you should join and also listen. Okay. So that is the thing. Okay. So here is the first question. I recommend to go from option A to option E rather than going from option E to option A. Okay. So the question is which of the following sequences are increasing? Increasing sequence. Okay. So all the 5 options are sequences. And I hope what that inside the bracket represent, right? So most of you know this, right? What is n power 5? It's the nth term in the sequence. Okay. Yeah, don't paste in the chat. As I said, I will now start a poll. You reply in the poll. Yes, I'm adding the poll. Just hold on. Okay. So I have posted the first poll. Those who have joined this session, you should all vote. So the question is very, very simple. It is not related to any of the week 3 contents. Okay. The question is, did you solve question 1, which is visible on the screen? So you can just vote yes, no, partially. So I have given 3 options. So once you are done, vote it here. Okay. So I see some 62, excluding me, my screen, and I have joined with another device. So 59 students are here. So so for standalone, this is very, very important. So you guys just join and just leave the phone. Okay.
Sir, where can I see the poll in the chat box?
Yeah, I think it will be visible in the chat, or it will come as a pop-up.
Okay, as of now, it's
Sir,
not.
sir,
It
it
Huh.
is
is
not.
visible in the activities.
Yeah,
Yeah,
click on the
it is not.
activities, it will be visible on the activities.
It is not at the chat box. You can see at the right corner, at the bottom.
Triangle-like structure.
Yes, sir. I can find it in the activity section.
Yes, yes. So you can click on the activities. There will be option poll, I guess. Okay, all right. So that's a nice suggestion. I will type. Okay, so how many are done? Can you just raise your hands? Okay, out of 70 odd, I can only see 12 people done it. Now it's the time to put your votes in the polls. Poll one, like whether
Can you
you
little
haven't, if you
zoom it?
haven't done, just click no. Sorry.
Can you zoom it the screen?
Sorry, I am unable to get it. Can you
No,
repeat?
no. Can you zoom it the screen, your screen, little bit?
Is my image?
Yeah, a little
Yeah, sir. It's difficult to see, especially the powers.
powers. What exactly numbers are there?
Sir, in PC it's fine. I think on mobile it will be a problem.
Okay, now is it okay?
Yeah, it's fine now. Thanks. Yeah,
All
it's
right. Mhm. Okay, fine. Okay, so last minute, please vote. Please do vote. I'm going to end the poll. Okay, so you can't answer it after 1 hour or whenever you come back and see. Okay, so now is the time. If you have done, click yes, done. If you haven't done, click no. If you are in between, you have got A, B, C options and you're unable to figure out D and E, Just click partially done. So 8:14, 8:15, I will close the poll. Okay. And for standalones, this is really important. It's not about joining the session. You should also answer here. Okay. So sorry. Okay. Okay, fine. I'm closing the poll now. All right. So let's discuss the solution. People with hands raised, you can lower your hands, please. If you have any doubt, then put it up.
Sir, how we access the poll?
Now I closed it. So for access, you need to click on that activities. I'll paste it. Vote. Polls. Click on.
I think it will be better
Active-
to show someone process once at once. Physically,
Okay.
yes.
So any volunteer for this? I don't think.
Yeah, there is a triangle-like structure.
Yes.
You
So
will
so
get
you
it
can, if possible, can you share and show?
Just a minute, I'm sharing my screen.
Sir, what?
Sorry.
I'm sharing my screen.
Yeah.
Just guide through it.
Right.
You
So
got my screen?
yes.
So seeing these tabs here. So rightmost tab it is activities. Just click on there and you will get the polls. And just go there and select your option and just say submit.
Sorry. Your voice is breaking.
Hello?
Yeah, your voice is breaking in between. Okay, so that is how it is. So the last thing, the rightmost bottom one, if you click on that activities, okay, then there is polls. Click on the polls, then you will be able to see poll 1, poll 2. Like this, I will create poll 2 for question 2, poll 3 for question 3, and it will be open for a certain period. Okay, so now you can't vote for the poll 1 because time is up. Okay, so please be ready for poll 2 for the second question. Okay.
Sir, what is the answer of question 1? It is ACD or?
That we will discuss now. That we will discuss.
Okay, sir.
Okay. So let me reshare my screen again. All right. So what about the first one? First one is very straightforward. So when you have a sequence with the nth term being n power 5, n raised to the power 5. Okay. So how does this sequence look? So the first term will be 1 power 5. Second term will be 2 power 5, 3 power 5, 4 power 5, and so on. So how is this sequence? So what kind of a sequence is this?
So it is increasing.
Increasing, right?
straightforward.
As n increases, n power 5 will increase. So this is increasing. Okay, straightforward. Fine. What about 1 by n square now? How does this sequence look? 1 by 1 square, 1 by 2 square,
Decreasing.
yeah, 1 by 3 square, and so on. You see, n increases. Where is n? N is in the denominator. So if n increases, If this increases, what happens to n square? N square will also increase, and n square is in the denominator. If the denominator increases, overall the fraction will decrease. Right? Overall 1 by n square will decrease. So therefore this is a
Decreasing
sequence. All right.
It is decreasing, no?
It will be decreasing. Now option C. Let's come to option C. So n power a fraction which is less than 1. What happens to this sequence?
It will be decreasing.
It will increase, sir.
So you should be careful here. So just write, if you are confused, just write some 4 terms. So how will
Excuse
it
me,
look?
sir. I have a doubt, sir. If n will be 0.2, then it will
N can't be 0.2. So n is.
But you don't declare that.
Sequences
assumed,
are
no?
like
N is
that,
natural
right?
number.
What is a sequence? It's a map from set of natural numbers to set of real numbers, right?
Oh, okay. If n will be in set of natural number, then it is okay. But if it will be real number,
No. It is evident that when you are talking about a sequence, and when you say this is your sequence an, okay, nth term of your sequence, nth term. So terms are represented with natural numbers, right? How do you count the terms? First term, second term, third term. There is no 1.2 term, right?
oh yes, sir, got it.
So that way n always represents the set of natural numbers. An, in other words, an is a real number that is present in the nth place of your sequence. Got it? So
Yes, sir.
and
So-
an. So n will always be like 1, 2, 3, 4, 5, 6. So this will always be a natural number. And what an is, what is the value of the first term will be taken by an. So it can be some 0.2. When n is 2, that means the second term in your sequence, what is the value that your second term takes? It can be some 22.5. So something like this. Ans can be real, whereas n will always be the natural number starting from 1 or starting from 0. So some sequences they will start from 0. Okay. But it will not be a real number. Okay. And here is, I hope I am clear at this point. Right. So n will always be.
So, sir, you mean if it is given that it is a sequence, then the numbers should be in natural number, but
Correct.
not real number.
But not real number. So when a representation like this, so this is the representation of a sequence. Okay. A sequence is denoted like this. Okay. Where this an is the value of the nth term, where n is the set of natural numbers. N comes from the set of natural. So nth term. So we start from first term, second term, third term, and so on and so forth. Okay.
Yeah, sir. And is it only one way to check the sequence is increasing or decreasing? Can we not solve this
We can. See, what is increasing sequence? How do you say
That will
a
be
sequence
better,
is
sir.
increasing? Sorry?
Sir, if n plus 1th term is greater than nth term, then it is increasing.
Correct. So how do you define increasing sequence? It should satisfy a condition. What is that condition? You have your sequence A1, A2, A3, and so on, an plus 1, an plus 2. We will also take an minus 1, and so on. So if I have to call this sequence an increasing sequence, then your A1 value should be less than or equal to A2 value. Your A2 value should be less than or equals to A3 value. So the next term should always be greater than your previous term, greater than or equal to your previous term. So likewise, in general, what you check is Either you check your nth term value is lesser than or equals to n plus 1th term for all n. So you start from 1, where n takes from 1, 2, 3, and so on. Okay. So for all n, this condition should be satisfied. Now, the sequence that you have is n power 5. Right. So this sequence is nth term is n power 5. N plus 1th term is n plus 1 whole power 5. So what is the condition between these two? So you just expand n plus 1 whole power 5. Right. You will have some n power 5 term plus some n power 4, n cube, n square. So you'll have all those things, right? So 5c1 n power 4, 5c2 n cube, 5c3 n square, 5c4 n plus 5c5 1. So you will have n power 5, and apart from that you will have more terms. So which is like this is greater than n power 5, and this is true for all n. So your 1 power 5 will be lesser than 2 power 5. Your 2 power 5 will be lesser than 3 power 5. So on so forth. And this is how you prove mathematically. Proving n power 5 is an increasing function. This is the condition you have to check. And it is very evident that from the binomial expansions, you can see that n plus 1 whole power 5, one term itself is n power 5, and there are some 5 terms added to it, and all the terms are positive. Right? So the overall this will always be greater than or equals to n power 5 for any n. So that's how you prove. But you don't need that analytical proofs in our, at least in the exams, you should not sit and solve analytically. Okay. So from the expression itself, you should be able to sense. And these are very, very important sequences. So something like n power k, where k is greater than 1 or k is greater than 0. Okay. So what happens to the sequence? How is the sequence behaving? When n power k, when k is negative, what happens to the sequence? So these are very trivial sequences, and you should know complete details about the sequence, like whether it is increasing or decreasing, will it be bounded or unbounded? Okay. So all these things you should really study them. Okay. So I will again put this. Okay, so let's come back to option C. So option C, will it be increasing or decreasing?
Increasing, sir.
Increasing.
1 power 2 by 3, 2 power 2 by 3, 3 power 2 by 3, and so on. So if you see again also, you'll see that 1 power 2 by 3 is simply 1, whereas 2 power 2 by 3 is cube root 4, okay, which is greater than 1. Cube root 4, and you have cube root 9. So cube root 4 will be lesser than cube root 9, and so on and so forth. So if your n is increasing, again n power 2 by 3 will also increase. As n increases, n power 2 by 3 will also increase. Finally, the whole sequence is an increasing function. Increasing sequence, sorry. Okay, so option A, option B, option C are very, in some sense, it is easier to understand. At least we can understand in one go. What about option?
It is also increasing, sir.
It is also increasing. And how do we sense? So now we can't write them explicitly. Even though you write, it takes time to.
No, sir. What I
get
did
it
was
right.
there is a difference of 2 between numerator and denominator.
Correct.
So what I did, I analyzed the pattern 1 upon 3, 2 by 4, 2 upon 4, 3 upon 5, 4 upon 6, and it is increasing. So from that, I concluded that this will also increase.
Right. Okay.
Obviously,
So I
limit is 0, but
correct. I partially agree. I mostly agree to that. But yeah, any other inputs from anybody?
Sir, I multiplied the numerator and denominator with the denominator. to get that a square minus b square at the numerator, and then I checked. I think
Okay.
it is not increasing.
Okay. Okay. So such kind of problems, you do this thing. So when the numerator and denominator has the same power or same order. Okay. So the numerator has something like root 2 n power half minus 1 divided by, again this also has 2 root 2 n power half plus 1. So if the powers are same, so what you try to do is you try to get this kind of term in the numerator. Okay, so what does that mean? So you need to have root 2 times n power half plus 1 in the numerator. How can I have that term
You
in the
can
numerator?
multiply.
Multiply?
You can multiply the whole term.
Ah, okay, that okay. Any
Sir,
other
we
way?
can write -1 as +1 -2.
Plus 1 minus 2, very good. So write this as root 2 n power half plus 1 minus 2. So what I did is, instead of -1, I just wrote the -1 as 1 minus 2, which both are same, right? And now divided by root 2 n power half plus 1. Now what is the advantage of writing in this way? I can have root 2 whole times n power half plus 1 minus 2 whole divided by root 2 n power half plus 1. So what I can do? I can split this separately and this separately. Right? Now if I do that, what will I have the red term become? The red portion will become, the
1.
numerator and denominator is
1.
same, it will just become 1.
1.
1 minus 2 by
2 by root 2 and
root 2n plus 1. Now you have only 1n in your whole expression. Right? Now look carefully. Your sequence increasing means you have to check what happens when my n increases. So n will start from 1 and it will increase to infinite. Right? So now what you have to see is, as n increases, what is happening to my overall sequence value? So if n increases, n is here. If n increases, what happens to root 2n?
It will go to infinity.
It will go to infinity. As n increases, this will also increase. If this increases, the whole denominator will increase.
Yes, sir.
Right? If my denominator is increasing, what happens to this fraction?
It will become 0.
Decrease or increase, not 0. So the denominator is increasing. What happens to the whole fraction? This
it
we
will
have seen
decrease.
It will
from
decrease.
part B. So
It
this
will
will
decrease.
decrease. And if this is decreasing, minus of it, what will happen to the negative of decreasing?
Increase.
Or you see in this way, 1 minus of the next terms, you are subtracting lesser and lesser. If you subtract lesser and lesser, overall sum, what will happen?
It will be increasing.
Yeah. So if you combine whole, it will increase. Okay. So these kind of problems, what if you have more than one places you have n, and you are sure that your numerator and denominator is having the same power, highest power is the same. So what you do is, there is some, you can do this kind of manipulation and convert the whole expression into an expression where you will have only one n term, one n. So from there you can decide easily. Okay, so this is also increasing. Is this clear to all of you?
Yes, sir.
So what we did? Okay,
Yes, sir, clear.
right.
But sir,
Hmm.
what if in numerator we have 3n in place of 2n? Then how can we solve?
Instead of 2, you have 3.
Yes, sir.
See, the thing is 3 times n or 2 times n. So this increasing, what it means is, as you increase n, the whole fraction is increasing. Okay. Instead of, in place of 2 itself, if your numerator divided by denominator is increasing, if you have 3 times, it will still increase, right? Further increase, right? Your
No,
numerator
sir.
is more.
His doubt is like here we took the common one out and made it 1 minus 2 by root 2
Okay,
and
okay,
1.
okay.
If it was not the same, if the numerator had a different term, how will we be able to?
Then it would be a little bit complicated.
Sir, should we then do the multiplication thing I did?
Then we have to do something like the denominator, you remove the square root. You try to remove the square root. And yeah, then you have to proceed. You have to split it into terms and then see what is happening. Or explicitly you compute some 3-4 values and see. Or the another way is you have your nth term, as I said, you have to check this condition, right? So if you have root 3n minus 1 divided by root 2n plus 1, this is your nth term. Your n plus 1 term would be 3 times n plus 1 minus 1 divided by square root 2 times n plus 1 plus 1. So using some math, you should really try to bring this kind of relationship between these two. Okay. So some inequalities you can think of is, you see 3n plus 3 is always greater than root 3n. Right. So this 3n plus 1. So this so root 3n is always lesser than or equals to root 3n plus 3. And you subtract 1 from both sides. You will have root 3n plus 3 minus 1. Okay. So and divided by root 2n plus 1 on both sides. Okay. So again, root 2n plus 1, if you divide it by root 2n plus 1 and if you divide by root 2n plus 2 plus 1, then you are dividing it by larger fraction in the denominator. So this will always be lesser than or equals to root 3n plus 3 minus 1 divided by root 2n plus 2 plus 1. Okay. So here this value is lesser than this value. Oh no. No. Uh-huh. Okay. Okay. Any ideas from anyone?
We can substitute 1, 2, 3 and check now, sir. For n.
You can do that. But if you want to
Sir,
prove
and in
this,
exams we'll be provided with the calculator, so it will be
yeah,
easier.
it will be. You will have the calculators. So that is the easiest way. But if you want to prove, that is what I said. So for exam point of view, don't sit and try to mathematically prove the things. So that will kill your time. Okay, but there
Yeah,
is a
sir.
mathematical proof. Maybe in the next class I will try to solve and come. I don't want to waste time here.
So I think this
Okay.
denominator is same now. We just cancel it out and we can compare the numerator and prove that the RHS is greater than LHS.
No, I'm going backwards. So I have taken this. This is very true. And then I have subtracted 1 on both sides, then divided this term on both sides. Now I have this term. This term I have. Now
Yes, sir.
somehow I have to prove that this term is greater than this term. So something like that. Okay. So, but okay. So let's skip this as of now. I will look into it. I will solve it and come back maybe in the next session.
Hello, sir.
Okay. Yeah.
Yes, sir. Before quiz one or qualifier, can you please give some tricks for
That we will do.
use
That
of
we will
scientific
do.
calculator?
Scientific calculator tricks.
Yeah, sir. In an exam, we had only calculator, scientific calculator in our.
Yeah. See, the thing is, you don't really need scientific calculators for math one. Okay. So yeah, you don't have to worry too much about how your quiz one is going to be. So we'll release the mock soon. So the graded assignments and practice assignments have little bit higher level because we are not monitoring you. Okay. So for the quiz, if you have done activity questions, if you have done enough practice of practice and graded, you'll release mock also. Mock, you attempt mock quiz one. So most of the
Okay.
questions will majorly test on your theoretical knowledge, like how much you understood from the lectures. And of course, this is a math course, so there will always be solving, but it won't involve complex calculations. So if you know multiplication, division.
Yes, sir. For
So that is
under root problem.
so that is what. So under root also, if at all needed, we will give you hints. But under root is like under root is available in the scientific calculator, right? Square root, you can put the value, right? Okay, we'll see. In revision session, we will see. We'll spend some 5 or 10 minutes to show you.
Okay, sir. Thank you.
Okay. All right. So let's come to the fifth and the difficult one. So this is okay. Now, what happens to option E? Will it be increasing or decreasing?
Decrease.
Decrease. So the easiest way, so if you see these kind of big expressions, don't get worried, okay? So you see the powers of n. So if the numerator power is higher and the coefficient that is getting multiplied to the numerator is positive, then the sequence will increase. Okay, so most of the sequences will increase. If your denominator power is higher, just like in this case, so this particular term will dominate, right? So n power 4, as n increases, n power 4 will increase rapidly compared to n square n terms, right? So if n is 10, 10 power 4 is 10,000, whereas 10 square is 100 only. So 10,000 and 100 when n is 10. And think about when n is 100, some 1000. So n power 4 will dominate like anything. Okay. So that is intuitively you can sense this will be decreasing. But if you have to prove this mathematically, then it takes a bit of time. I will not write the whole things, but I will leave it to you guys in between. Okay. So the numerator, you can take out 4 common, and in the denominator you can take 3 common, right? So this 4 by 3 doesn't play any role, so you can skip this. So if this term is increasing, 4 by 3 of that will increase. If that term is decreasing, 4 by 3 of that will decrease, right? So you can ignore that 4 by 3 and just look at this expression. So now if you see here, you don't have, again, if you see fractions like this, the best thing is try to get in the numerator, try to add or subtract terms and try to get a term which is equal to the denominator. So in the numerator, if I add n power 4 and subtract n power 4, okay, and this will be, you can rewrite this as n power 4 plus n square plus 1 plus n minus n power 4 divided by n power 4 plus n square plus 1. See, I ignored 4 by 3. Okay, so you can ignore that. Now what happens is I can simplify this as 1 plus n by n power 4 n plus n square plus 1 minus n power 4 by n power 4 plus n square plus 1. Now what you do is, you see this expression again, it has same power in the numerator and denominator. The dash power is same in the numerator and denominator. So what you do, you divide by n power 4 in the numerator and denominator. You will get 1 by 1 plus 1 by n square plus 1 by n power 4. Here also you do divide by n in the numerator and denominator. You will get n cube plus n plus 1 by n. Now see, now observe. So once everything is in the denominator, so you know where this goes. Where this goes. As n increases, where these terms will go. Right? Everything you know. So observe this thing. What happens to 1 by n square and 1 by n power 4 as n increases? Both will decrease. Right? If both decreases, and that is decreasing in the denominator, overall the expression will increase. Right? So if this increases, minus, so you see this minus, this overall thing will decrease. Not only that, as n increases, this term will also, if you see as n increases, this goes to 0, but these two are dominating terms, like this goes to infinite. And if this is going to infinite, big term, 1 by of infinite will also go below 0. So the positive term is also decreasing. So this is decreasing, this is also decreasing. Overall, it will decrease. Okay. So yeah, just write these expressions and think for a while, you will understand. Okay, so this will decrease. This is a decreasing sequence. Okay, so the answer is A, C, and D. Okay. So that is how you solve question 1. Now question 2 and question 3 are interlinked. And the so consider a sequence AN such that your first term is 1. And we have given a recurrence relation to define the sequence. Right? So you would have studied what recurrence relations are. So the next term will depend on the previous term or previous two terms. It depends on the recurrence relation that is given. Here the relation given is an plus 1. The next term is actually equal to square root 12 plus an for all n greater than or equals to 1. The first part of the question is which of the following options are correct, and options are whether the sequence is increasing, decreasing, bounded above, bounded below. And the second part is if at all sequence is convergent, find the limit of the sequence an. Okay, so let me create pole 2. Okay, so pole 2 is live now. So if you are done solving, only then come and vote here. Okay, it takes some time. Take time. Or you can take time till 8:55. Solve both the questions at a go. No, don't put your answers in the chat. Okay. So if you're done solving, just vote in the poll. So I think I have pinned my message also, so you can check. Okay, so far I have received only 14 votes. I expect people are trying this problem. So once done, cast your vote in the poll. So you can solve this problem till 8:55. So 8:55 will close the poll. Okay, so for those who have solved these two problems, so this is like a bonus thing, so which is not in the graded assignments or anything anywhere. But think what happens to the sequence if your first term is varying. Okay, so if your first term is, what I gave is your first term as 1 here. But think what happens to the sequence if my first term is 4, and what happens to my sequence if my first term is 5. Okay, so what happens, I mean, will it be increasing again, the same things? So will the answer be the same irrespective of what the initial value is, or will the answer change? So this is one good thing to think about. Okay, so give it a thought. Okay, so the last minute, all the standalone students, please cast your vote. Okay, so if you haven't done the problem, just cast it as no. So there is an option available, no. Please click no. If you have done partially, then please click partially done. If you have done solving it, click yes, done. And yeah, so the responses given by you will be treated as the attendance. Okay. Okay, so yeah, so 8:55, I'm ending the poll. All right. Okay, so now we will discuss how to solve these kind of problems. Okay, so what we know? Yeah, we know that the first term is given to us a1, which is 1, and the later terms are dependent on the previous term, and this is how they are dependent. So if I write explicitly, so one good thing in week 3 is it is on sequences. So if you are confused, too confused, where to start, then write down the sequence explicitly. Sit and write. So if you have time, you have just write it down. So you have the first term with you. For getting the second term, all you have to do is substitute n is equals to 1 in this equation. So if you substitute, you will get a2, which is like 12 plus a1, which is square root 12 plus 1, which is square root 13. Write a3. 13 plus a1, which is square root 12 plus 1, which is square root 13. Write a2, which is square root 12 plus 1, which is square root 13. Write a3. 13 plus a1, which is square root 12 plus 1, which is square root 13. Write a3. 13 plus a1, which is square root 12 plus 1, which is square root 13. Write a3. 13 plus a1, which is square root 12 plus 1, which is square root 13. Write a3. 13 plus a1, which is square root 12 plus 1, which is square root 13. Write a3. 13 plus a1, which is square root 12 plus 1, which is square root 13. Write a3. 13 plus a1, which is square root 12 plus 1, which is square root 13. Write a3. 13 plus a1, which is square root 12 plus 1, which is square root 13. Write a3. 13 plus a1, which is square Now what is A3? 12 plus A2. So this is, you have to substitute n is equals to 1. This is n is equals to 2. And A2 you have it as root 13, which is square root of 12 plus square root 13. Right? If you write few more, like when n is 3 and n is 4, what will you have? You will have A4 term, A5 term. How is A4 will look? 12 plus A3, and A3 is square root 12 plus root 13. Similarly, A5 if you write, you will see that this will be like 12 plus 12 plus 12 plus root 13. So now you slowly start observing a pattern. Right? So you have root 13 initially. Actually, A1 is 1. So you have 1. Then you have root 13. Then you have square root 12 plus root 13. Then you have square root 12 plus square root 12 plus root 13. And then you have square root 12 plus 12 plus 12 plus root 13. If I write few more terms, how will a 100 or something larger term will look? You will have 12 plus 12 plus 12 plus and so on. You'll have 12 plus root 13. Right? So there will be some 98 12s in between. So something like this. Now, what is the conclusion? So you can write this explicitly like this. And what can you sense from this?
It is increasing.
So 1 to root 13, and root 13, if you have calculators, you can just put it in the calculator and see what is root 13 is. And then what is root 12 plus root 13 is. Okay. So then you will see, you will start observing that this will increase. But it is increasing. And you have the lower bound with you, bounded below. Right? Your first term is 1. And no other term is less than or equals to 1. Therefore, 1 acts as your lower bound.
Lower bound.
Correct. If you have a lower bound, then the sequence is bounded below. So this you can straight away say. This also you can say.
And
If
sir,
you write it.
since you have asked the limit, it means it is bounded above 2.
Oh, okay.
Yes, sir,
So
bounded amount also.
that way, so if you have, that is an advantage. If you see the next question, since we are asking find the limit of the sequence and it is an NAT.
Yes, sir.
Right. So therefore it will have an answer. So that means if we are asking for a limit, then it is like convergent. So if it is
Yes, sir, it's
convergent,
converging.
so it should be bounded above. So that way also you can easily guess, but there are few other ways also. So this is explicitly, if you don't know any concepts, week 3 you are unable to understand anything. The least thing you can do is write the terms explicitly and see. But if you have some understanding of the concepts and all, then for increasing, what you have to do? All you have to do is an plus 1 is greater than or equals to an. So this is what you have to check.
It's
Right?
bounded above.
Yeah, it is bounded above. Yeah, it is bounded above. This is also correct.
Sir,
Okay.
can you tell me how to calculate the limit of this so we can conclude that it is bounded above?
We can compute the limit also. That is also there. But if you see, if you write an plus 1, how will this look? This will have 12 plus 12 plus 12 plus and so on plus 12 plus root 13. Right? Like this, if I go for a larger number, something like a infinite, if I say, let's not say infinite, very large number and capital N, very, very large. How will this look? This will also look the same, but I will have few more terms. 12 plus 12 plus 12 and so on in between. There will be too many terms plus root 13. And as we know, if the sequence limit exists, this capital N tends to infinite, this will be a number. some number x which is a real number, and that is the limit value, correct? So if this is x, what will this be?
X.
Huh. So you observe this thing. Now capital N is almost infinite. So you have infinite terms in between. If I just ignore the first term, from next, if you closely observe, you will have again the same thing. Square root 12 plus square root 12 plus square root 12 plus and so on. Square root 12 plus square root 13, which is what x is. Right? So this is also x. So square root 12 plus x is actually equals to x. Right? Now all I have to do is I have to solve for x. I square on both sides. I'll have 12 plus x is equals to x square. And I will write x square minus x, everything on one side. X square minus x minus 12 is equals to 0. Now it's a quadratic equation.
Yes, sir.
Put
N
out your
minus
knowledge from week 1. So x
Yes,
will
sir.
be 4 or
4
minus
comma
3.
minus 3.
Minus
Minus
3.
3. But if you see, this is square root of something. So what is square root of any number is? Can it be
always
negative?
positive.
Always positive.
So here x is greater than 0. So that means minus 3 is not a possibility. Right? So therefore the only possible value for x is 4.
4.
Right? So
4,
just
sir.
see whether 4 satisfies your condition or not. This is the condition that we said. So square root 12 plus x should be equal to your x. So if I put 4 in place of x, 12 plus 4 is 16, square root 16 is 4.
4.
So we are getting that back. Yeah.
Yes, sir. 4.
Sir, if you put x as minus 3 also inside the root, it is positive only, right? Sir?
So okay, so if you put x as minus 3, you will have square root 12 minus 3, which is square root 9. But what is square root 9?
Plus or minus 3.
Plus
No,
3.
square root 9 is plus 3.
Oh, yes. Sorry.
Square
Yes.
root is always positive. Okay.
Oh, yes. Sir. Yeah.
So that
Yes,
is why x is equals to minus 3 is not a possibility. Okay. So there is one nice way also. So you know your an plus 1 is square root 12 plus an. Correct? So all I need to prove is if I have my nth term being less than or equals to 4, if I can prove the next term an plus 1 is also less than or equals to 4, then I am guaranteed that no term in my sequence will cross 4. Right? So if this, then if I can prove this, then I am done. For any n, if my an is less than or equals to 4, my an plus 1, if it is less than or equals to 4, no term will cross 4.
Sir, it means you answered the next two questions.
Hello, sir.
Huh. Yeah.
Sir, can we say if a sequence is increasing or decreasing on the basis of differentiation, sir?
I am not sure why differentiation came. I read the comment that somebody has put. See, this is n is not continuous here. N is a discrete value. Small n takes value 1, value 2, value 3, value 4, and so on. Right. So how can you differentiate a discrete function?
Okay.
That's not possible, right? So if you plot n versus an, so if you plot n and an, so you will have at 1 you will have some value, and at 2 the next point will be at 2. So at 2 there will be some other value. At 3 there will be some other value. At 4 there will be some other value, which are far from each other. Points are very far from each other, right? And it is not continuous basically. It itself is not continuous. If it is not continuous, you can't differentiate also. Got
Hello,
it?
Sir,
sir.
but we are able to draw the graph without lifting the pen, right? So then it is continuous, sir.
How can you draw?
I mean, sir, after we mark the points, like we are just joining the points, right?
How do you join? I can join this like this also, right? So you are interpolating. So you are doing interpolation. So you have some 10 points, and within the 10 points, you are joining them carefully so that it forms a function, which is not even discussed anyway.
The values are
Hello,
not
sir.
defined for numbers which are not natural, right?
Not
So,
natural numbers,
Hmm.
right? So there is no value here. There is no function here. Okay. So these are just points at natural numbers.
Okay.
Okay. So these are just
Hello, sir.
points. These are not curves. Yes.
Sir, as we consider n is not go above the 4, then we
N
can call is as a bounded sequence.
n will go to infinite. Small n.
Okay.
Okay. So the thing is, see, sequences will not have finite terms. Okay. So that is the base thing you should learn. You should learn what a sequence is. Sequences will have infinite terms. Okay. So 1, 2, 3, 4 is not like it's a list. It's not a sequence. When you say in mathematics, at least in the calculus, when you talk about sequences, sequences won't stop. Okay, it will go till
Okay.
infinite. Okay, so n will not stop at 4 or 100 or 1000, nor anywhere near to the highest number that you know. It will go till infinite.
Yes,
Okay.
sir, but we consider that the 4 is the value of n is less than or equals to 4.
That is term value. So an is different from small n. So that is what I'm saying. So here, see, the thing is, n is different, an is different. Okay, so n is the term. Which term? An is the
Okay.
value of the term. Okay,
Yes.
so here I wrote an less than or equals to 4 means none of my term values, no term in my sequence is greater than 4. Value, not the term. Okay, so if you see that plots, stem plots. So if you
Yes.
plot stem plots, then what I mean is, so this an less than or equals to 4 implies that you plot all the stems for all infinite values. If this is 4, none of your stem will cross height 4. That is what height represents the value, and this 1, 2, 3, 4 is the n. Okay, so here we are talking
Okay.
about the height of the stem.
Okay.
Okay. Okay, so
sir, this technique which we had used for assuming that we had taken x as infinity, it is similar to something which we had used in ESTC, like for calculating infinite ladder resistance. If you remove something from, like if there's an infinite resistance ladder, and if you consider one, if you remove one particular thing, it's still infinite resistance. We had it's kind of
ha
similar to that.
ha ha ha. So that is what we did here. Okay. So anyway, so is this okay? At least this part, what we did in
Sir,
this page.
I didn't get, sir, how it is bonded above also.
Bounded above. Bounded below is clear, huh?
Yeah, yes, sir, that is clear.
So that is what. So bounded above. So if I say an in order to prove bounded above thing, what do I need? I need some capital M such that all my terms in the sequence has values lesser than or equals to capital M. Right? This is the condition for bounded above. So from the word itself, you should understand bounded above. So none of your term values cross the capital M, goes above capital M. If you can find such a capital M, then the sequence is bounded above. Is this
So,
clear?
sir, can we say that every increasing function is bounded above?
No, not every sequence is bounded above, right? You take the very easy sequence 1, 2, 3, 4, 5. Can you find a real number capital M such that no term in your sequence is below, or such that all the terms in your sequence is lesser than or equals to that real number? Can you give me one real number?
Sir, since limit is 4, so we can take 4, 5, 6, 7, anything we can take, and it will be greater than an.
Correct. So that is what. So limit is 4. That I agree. But for proving part, so if you are not sure that, see, this is not given, this part is not given, only the above part is given, what will you do? So you have to prove that, right? So is it bounded above or not? Okay. Is this okay? There are increasing sequences which are not bounded above. So this sequence is increasing, but not bounded. So you can't come up with a real number and say this is the real number which is greater than or equals to all the terms in the sequence. Okay, so there will always exist a real number or a number in this sequence which will always be greater than what the number you give. So if your capital M is some 1000, then there is 1001th term. The value of the 1001th term is 1001, which is greater than 1000. Okay, so you can't come up with any M. So you give me any large M. Even there is one term plus 1 will have more value than this capital M. Okay, so this is not bounded above. So bounded above means there should exist a capital M, and this M is a real number. If all your terms are lesser than or equals to that capital M, such a sequence is called bounded above sequence, and this M is called an upper bound. Upper bound of that sequence. Okay. So now in our sequence, what we have is your an plus 1 is square root 12 plus an. So now you wanted to prove that this sequence is bounded above. Okay. So for that, what I took is, I just took this. If my an is less than or equals to capital M, okay. So can I prove something like my next term is also lesser than or equals to capital M, and then I can generalize it, right? So for that, what I took is, it's like careful manipulation, that's it. So I know that I know that my a1 is lesser than or equals to 4, because a1 we have, a1 is 1. So 1 lesser than or equals to 4, that I know. So I add 12 on both sides. So 12 plus a1 is lesser than or equals to 12 plus 4, and take square root on both sides. Okay. So if you see this, square root 12 plus a1 is your a2 term, and your a2 is also lesser than or equals to 4 on the right side. Similarly, if your a2 is lesser than or equals to 4, again you add 12 on both sides, take square root on both sides. You will see that a3 will also be lesser than or equals to 4. So in general, if you are taken an, if your nth term is lesser than or equals to 4, then you add 12 on both sides and take square root. Okay. So this is your an plus 1, which is lesser than or equals to 4. So you will start observing that all your terms starting from the first term till your last term. So this generalized, this n can be anything. So if your an, if your a 100th term is lesser than or equals to 4, what I proved is your 101th term will also be lesser than or equals to 4. Similarly, if I look at some big 1 lakh term, a 1 lakh term is lesser than or equals to 4. Our 1 lakh 1th term will also be lesser than or equals to 4. So this is called, anybody can guess this, what kind of proof this is? So I have a base case. Then I took it is true for an. Then I proved it is true for an plus 1 also.
It's a mathematical induction.
Principle of mathematical induction. Okay, it's a very standard way of proving mathematical proofs. So anything including this natural numbers or some sequence. So we will use principle of mathematical induction. But so that's what I'm saying. So these kind of proofs are not required for you, like for this particular course at least. So we are not expecting these things. Rather, we expect these things. So how are you analyzing a sequence? Given a sequence to you, were you able to analyze how the sequence is behaving? Okay, either looking them pictorially by drawing stem plots or writing them explicitly and observing some changes, or look at the expressions. So your an plus 1 is square root 12 plus an. So how does square root 12 plus an behave as n increases? Okay, so these kind of understandings are required. And were you able to see, the thing is, were you able to get whether the sequence is increasing or decreasing? Were you able to understand whether the sequence is bounded below or bounded above? And if it is bounded above and it is increasing by monotone convergence theorem, you can say limit exists, and you can find the limit also. Yes.
Yes, sir, clear. Thanks.
Okay. And once you know that this particular sequence satisfies this monotone convergence theorem, okay, what you can do is you can use limit n tends to infinite on both sides here. So you see, so limit n tends to infinite, an plus 1 will be limit n tends to infinite square root 12 plus an. Right. So you know, as limit n tends to infinite, an plus 1, so all the terms in your sequence will take more or less the same value. That is what convergence means, right? So this value, if you take L, and on the right side also you 12 plus limit n tends to infinite an, this will also be L. Then the equation that we got before, you will have the same equation, L is equals to square root 12 plus L. Instead of X, you would have written it in terms of the limit value. Okay, so both ways. So this I expect, or at least I expect, you need to have these kind of intuitions. Right? Given the sequence or the information, what all things can you infer about the sequence? Okay, that is in. Okay, any quick answers for this?
Yes, sir. For 4, it will become a constant. All terms
Very good.
will be 4. And for 5, it will decrease because limit is 4, so it will come down to 4. So it will decreasing function.
Very good. Very good. Yeah. So again, so I will not spend too much time. It is not that much required, but so if you are a naught, initially a naught is starting from 1, right? A naught is 1 or a1, right? So a1 is 1. A2 is square root 13. A3 is square root 12 plus root 13, which is slightly greater than root 13. Okay, so 1 root 13 square root 12 plus root 13. So likewise, so it will kind of, if you are starting from 1, your graph will look somewhat like this. If you plot your sequence values, it will kind of look like this. Whereas if you start from 4, you will observe that if your A1 is 4, your A2 will also be 4, your A3 will also be 4. So 4, 4, 4, 4, a constant sequence. Okay, a straight line. This is 4. Anything above 4, if you're starting from above 4, something like 5. Okay, so if you are starting from 5, what is this? Let's take it. What happens is you start from 5, slowly the sequence will reduce, it will decrease. Okay, so it depends on where you start, where your sequence is starting. Okay, so even though the recurrence relation is the same, the behavior of the graph or behavior of the sequence changes when you change the initial value. Okay, so that is it. That is slightly okay. That is not that important for if you think of it as an exam point of view, but these kind of interesting things you should be able to understand, and you will definitely appreciate it if you have done it on your own. Okay, so that is not that important if you are just looking in terms of exam and scoring well. Okay, so let's do the next problem. So here is the sequence an such that your an plus 1. So let me expand this. So your an plus 1 is 2an plus 1 divided by an plus 1. And first term in your sequence is 1. Now what you have to answer is whether the sequence is decreasing or increasing, or and is it unbounded or bounded. Okay, again I will create a poll for this and answer in the poll. Yeah, the poll is live now. Okay, so all of you can take 2 to 3 minutes. I don't think more than 3 minutes is required for this particular problem. Okay, so maybe I will end the poll by 9:29. Sorry. Okay, so before that, please do cast your vote. Okay. Yeah, so cast your votes now. I'm going to end the poll. Okay, again, for standalone guys, this is important. Okay, so I'll give you one more minute, but before that, I thought somebody will ask, how did you choose 4 here? Like, why did I choose 4? Or how do we know if I don't know the limit value? How did I choose 4? Because I know the limit value. But in exam or if the question is different, anyone? Is my question clear? So I did principle of mathematical induction, but principle of mathematical induction is to prove something, show something, right? So I already know that the limit value is 4. So I know the upper bound will be 4. That is why I have chosen 4. Okay, it's kind of reverse engineering I did. So I know the solution. I kind of manipulated the backward, like proof. Okay, so the thing is, it need not be 4. Okay, I just took 4 because I will get back 4 again. You just take this capital M. Okay, so then add 12 on both sides. Okay, so what will you get? You take this. An less than or equals to M is what you have to prove. If you add 12 on both sides, you will have 12 plus capital M. You take square root on both sides. 12 plus An less than or equals to 12 plus capital M square root. Okay. And this is An plus 1. And carefully look at this. So if it has to be lesser than or equals to M, if it is lesser than or equals to M, then you are done. So your An plus 1 will be lesser than or equals to capital M. Now if this has to be true.
Excuse me.
Sorry.
Sir, how can we assume that an will be lesser than and equal to m? Because as we know, it is an increasing function. Then,
N is an increasing function, and as it increases, and if it is bounded above, then the limit exists. Correct?
yes, yes, sir.
So in order to prove bounded above, the condition is this. So if my sequence values are lesser than or equals to capital M, then it will be bounded above. Right? So this is the condition for bounded above thing. And why do I need bounded above? Because I know that the sequence is increasing. If it is not bounded above, then limit will not exist. Right? As simple as that. So if it is increasing, and if I had to check for bounded above thing, this is the condition for checking bounded above. So I need some capital M such that all my sequence terms are lesser than or equals to capital M. If I can find such an M, then I am done. So if I use that condition, I will reach this condition. So will there exist any capital M such that my capital M is greater than square root 12 plus M? There are infinitely many possible values. Starting from M is equals to 4, any value greater than 4, this will satisfy. Right? You can check. You take M is equals to 10. If your nth term is lesser than or equals to 10, your n plus 1th term will also be lesser than or equals to 10. Okay, so take M is equals to 10 and see. Not only 4. That is what I wanted to conclude. So you take this and you can prove for, you have to get a particular M. That's it. One value for capital M is sufficient to say it is bounded above. Okay, so is this clear now? 4 is not a sacred term, sacred value. So 4 is not that special. Okay, so you can pick any value greater than 4, you can prove. If your an is lesser than or equals to that value, your an plus 1 will also be lesser than or equals to that value. Yeah. So, all right. Let me end the poll. What is the answer for this one?
It is increasing, sir.
It is increasing, and is it bounded above?
Yes, sir, bounded.
Bounded. Okay. Again, how do we do this? Again, you write this big expression 2an plus 1 by an plus 1 as 2an plus 2 minus 1. So 1 I will write it as plus 2 minus 1, an plus 1. And if you simplify this, you will get, so take this as one expression, this as another. So you'll have 2an plus 2 by an plus 1, which is 2, minus 1 by an plus 1. Okay, so this will be your an plus 1. Now, again, the same thing. You know the first term, write the first term. For getting the second term, use this recurrence relation. Substitute n is equals to 1. You get a2 as 2 minus 1 by 1 plus 1, which is 2 minus 1 half, which is 3 by 2. So that will be your second term, which is 3 by 2. And
third will be 8 by 5.
So a3 will be 2 minus 1 by 3 by 2 plus 1. So a2 plus 1. So 3 by 2 plus 1. It will be 2 minus 2 by 5. Right? It will become 8 by 5. And like this, if you write it explicitly, then it is very clear straight away. Okay. And it will be increasing. How can I prove this is bounded?
Sir,
Sir, it is obviously bounded below, and I calculated the limit. It came 1.618. So from that, and it is increasing. So I concluded it is bounded above 2.
Okay. So bounded should be concluded before computing limit. Okay, if you compute the limit, if you are getting limit, then it is okay. But theoretically, you have to conclude bounded first, then you have to go for the limit. Okay. All right. Again, you can use the same logic which I just explained. All you need is this expression, right? So if you an less than or equals to 2, okay. If I can prove again an plus 1 is less than or equals to 2, then for any n, my values will be lesser than or equals to 2. Right? So if an is lesser than or equals to 2, an plus 1 will be less than or equals to 3. And then what you do is you manipulate and try to bring an plus 1 on the left hand side. Okay. So 1 by an plus 1 will be greater than or equals to 1 by 3. So if you invert, the sign will also change. And again, minus 1 by an plus 1. If you multiply negative number, sign will again change. Add 2 on both sides. 2 minus 1 by 3 lesser than or equals to 2 minus 1 by 3.
Sir, it will be 2 minus 1 by an plus 1.
1 by an plus 1. So this is 5 by 3 then. Okay. I'm missing something. So what is the limit value? 5 by? It's not 5 by 6. Okay. So let me take capital M only. This will be M plus 1. This will be 1 by M plus 1. This will be M plus 1. And this will be M plus 1. Okay. So if I can get a capital M such that 2 minus 1 by M plus 1 is lesser than or equals to M. Okay. So 2M minus 2M plus 2 minus 1 divided by M plus 1 should be lesser than or equals to M. So 2M plus 1 will be lesser than or equals to M into M plus 1. And I'll have M square plus M. Okay. And this is 2M plus 1 lesser. So if I bring everything on one side, M square minus M minus 1 should be greater than or equals to 0. So I have to find an M such that this is true. Right? I can actually take M to be 3. Right? So 3 square minus 3 minus 1, which is positive. So if you take 3, then it will work. So this is just to prove, it's not to find the limit. This is just to get that one value for capital M such that all your terms are lesser than or equals to that value. And you can say it is bounded above simply. So if your an is less than or equals to 3, then again an plus 1 will be less than or equals to 4. 1 by an plus 1 will be greater than or equals to 1 by 4. So everything you can do. Minus 1 by an plus 1 is lesser than or equals to minus 1 by 4. Again, you do 2 minus of minus an plus 1 lesser than or equals to 2 minus 1 by 4. What is this? Yeah. See, this is an plus 1. So this an plus 1 will be lesser than or equals to 7 by 4. And this 7 by 4, we are sure that this is lesser than or equals to 3. So even here also, even with 2 also it will work. I don't know why I missed. So if your an is less than or equals to 3, what we proved is your an plus 1 will also be lesser than or equals to 3. Even further lesser than an itself.
Yes, sir. The limit is 1.618.
So by looking at this, you can actually conclude that this sequence is bounded above also. So it is increasing and it is bounded above. So this sequence is bounded below as well as bounded above. Therefore, it is bounded and it is also increasing. Okay. Any doubt here? All right. So let's go to the final problem which we have for today. Imagine you have a bottle with 1 liter of liquid A. I think this is one of same your graded assignment. Just I just change the values a little bit. So you take out 0.2 liters, add water, mix it thoroughly, and then repeat the process. If we repeat the process 3 more times, then how much in liters of liquid A is left in the mixture? Enter the answer. Enter the correct answer in 2 decimal places. It's not enter. No need to enter. Write the correct answer in 2 decimal. Okay, so I am creating the final poll. Don't answer in the chat. Anyway, that is not correct.
Yes, sir. Done.
Okay. Also, if you have subscribed to the YouTube channel, then you can also access the previous term. You can also look at the previous term live sessions there. Okay. So I think we have discussed many short tricks with respect to week 3 in those sessions. Okay. Okay. So for this particular problem, I will give you guys. Okay. So anyway, I received 10 words, already 11. So I will give you some 2 more minutes. Don't answer in the chat, Aditya. No, am I speaking some other language or? I don't know. Or is my English too bad? So do not answer in the chat. Right? So 5 words. I just used 5 words. Yes. This is the last question we have for today. Which can mix with water. Okay. Something like milk. Alright, 2 more minutes. So week 4 has been released. Okay, so those who are done with week 3 start watching week 4 lectures. Okay, so and on Friday, I will quickly summarize. So I won't spend too much time on discussing what is function, how do we compute limit of a function. So we will solve problems, but we will do summary first. And with that summary again, the word itself should tell you something. So it's not the whole detailed lecture. So it is going to be a summary. And if you have any doubts, we will put a discussion forum post or discourse post saying what all topics I will be covering. Okay, so you will receive maybe on Thursday morning. So you will receive. Look at the contents that I'm going to discuss. If you need few more to be discussed on that particular live session, please reply to that mail thread saying so and so concept I want you to cover. Okay. So if you don't reply anything, what I think is whatever I gave is sufficient. So I will discuss those things only. All right. Am I clear? So on Friday's session, we will be doing the summary of week 4, not the whole week 4. We have only 1 hour. So Friday session, we will do the summary. And Sunday session, we will do problem solving. Okay, so like maybe from activity questions or practice assignment. We will take the questions and try to solve it. And on Tuesday again, we will do solve with us. Solve with us is like I will come up with some questions which are replicas of graded assignment, and we will solve them collectively together. Okay. Attendance calendar. Okay, maybe I will have to talk to the support team. I'm not sure what this attendance calendar is. Anyway, I'll talk and discuss. If it is available for other subjects, we will also make it available for math. Yeah, short notes. Week 4, I have a short notes I can share you. Or the things which I annotate on Friday, I will just share it with you.
Hello, sir.
Yeah.
Sir, and regarding the standalone status, I've been asking for the past 2 sessions. Like, I mean, we did submit the form, sir, but we did not get any confirmation as to like now if you're being considered as a standalone or a dual degree student.
You applied. So what you filled in the form?
We feel that we are doing a dual degree and the proof, sir.
That is sufficient. So back end, it will be noted, and you will be treated as a dual degree student.
Okay, sir.
Okay, so I am ending the poll, and we only have 8 more minutes to discuss this problem. Okay, so yeah, so let me end. All right. So, what is this question to do in week 3? How does it related to week 3 concepts? So, let's say we have a liquid A in the bottle, and it is of 1 liter. Right? Initially, we have 1 liter of liquid. And let's also denote AN as amount of liquid left in the bottle after n repetitions. Okay. So what is the process actually? So you have a bowl and you have the liquid. So what we are doing is you have 1 liter in it. We are removing 0.2 liters out, and we are replacing that 0.2 liters by water. Right? So let's say VA denotes the volume or the amount of liquid A, and VW is the volume of water after the iterations. We will write them initially. We have 1 liter of liquid A, 0 liters of water. This is 0th. So we didn't do anything. This is the initial. So n is equals to 0. N is equals to 1. What will happen? What happens to the volume of A? Liquid A. So we removed 0.2 liters.
0.8.
So it will be 0.8.
So we are removing 0.2 liters. So 1 minus 0.2, which is 0.8. Right? And we replaced it with water. So amount of water will be 0.2. Now, when I repeat the same process again, what is going to happen? This is 0.8. So 0.1 to so initially it is 1 liter. Next it has the liquid A left is 0.8 liters. Now in the next repetition, what am I going to do? The next repetition, I have 0.8 liquid and also I have water, 0.2 water. And this is mixed thoroughly. If I remove 0.2 liters from this, how much amount of water and how much amount of liquid will come out? So will 0.2 liters of liquid A come out? No, right?
No, sir.
So it will again come out in the fraction of the volumes of liquid A and water that it has. So if I remove 0.2 liters out, 80% of 0.2 liters will be our liquid A and remaining 20% will be water coming out. Right? So 0.8 of 8 times 0.8.
Sir, 0.8 into
0.2.
Yes,
Yeah.
sir.
So 0.8 into 0.2. So I am removing 0.2 liters out. Out of the 0.2 liters, 80% of 0.2 will be liquid A coming out. Right? And remaining will be the water. So the 0.2, 20% of 0.2 will be the water. Will come out. And everything will be replaced by water, 0.2 liters. Okay. So after, so 0.8 times 0.2 will be removed further. Right. So from 0.8 times 0.2 is removed. So the remaining volume of volume of the liquid left is 0.8 minus 0.8 times 0.2, which again you can write this as 0.8 times 1 minus 0.2, which will give you 0.8 whole square. So initially it has 1. Then after first round, it has 0.8. After the second repetition, it has 0.8 whole square. Right? And if you see the third repetition, you will observe that you do all these things. You do intuitively, you see what happens, how much amount of liquid will come out, how much amount of water comes out, and everything will be replaced by water. If you do that, and finally if you simplify, you will get 0.8 whole cube. So like this, if you do this process some 10 times or k times, n is equals to k, then the amount left, the volume of liquid A left will be 0.8 whole power k. And this forms a sequence. So you don't have to do all these things. Okay, so you should understand that every time you repeat the process, 80% of the liquid will remain from the previous. Right? So currently if you have AN, if you repeat the process, your AN plus 1 will be 0.8 times AN. Okay, so where AN is the amount of liquid left in the bottle after n repetitions. So in the n plus 1, if you repeat the process once again, the amount left, the amount of liquid A left in the container will be 0.8 times to the previous. So this is the recurrence relation you form, and you know A1 or A0, right? So A0 is 1, A1 is 0.8. So from there you can write the nth term. So an will simply be 0.8 whole power n. Okay, so now what is the question if we repeat the process 3 more times. So it is already done one time and you are doing it 3 more times. So overall, it will be
N
4
will be
times.
4.
Yes. So n will be 4. So therefore the answer will be A4 is 0.8 power 4, which is approximately 0.64 times 0.64. 2 cube 2 power 12, 2048, 4096. So something like 0.4096. Just cross verify whether this is correct or not. So
Yes, sir, that's the answer.
this is actually equal to it. Is not
Yes,
even
sir,
approximate.
that is correct. Yes, sir, that is the answer.
Sir,
Yeah.
can you show the before slide once?
Yes. Yeah, any doubt?
No doubts.
Okay. Okay, so is this clear? This thing?
Yes, sir.
How this
Yes, sir,
every
clear.
time how this 80% of the previous volume will remain in the next repetition. So that will solve us the problem. So if you know directly this, then it's fine. And how we got this is by observations. Okay. Yeah, so I think these are the things that I wanted to discuss today. And now hopefully you will be able to solve at least 60% of your graded assignment questions. But for the next 40%, remaining 40%, either you have to solve it on your own or join into some student communities. They will share you the answers. Okay. All right. So we will meet on Friday. But before coming to the Friday session, I expect everybody to watch week 4 lectures at least partially, half of it, and come.
So how can we join the student communities?
Sorry, how can you?
Join the student communities.
That I can't say.